Hi everybody. So today, well first my name is Jewel and today we're going to be making a lemon battery for my interactive advanced concept presentation. So I already have the lemon battery set up, but I'll just go ahead and walk through kind of the materials and how I set it up and the things that I was taking into consideration when I was making this lemon battery. So obviously I have one lemon. When I was kind of researching this, I did see that there are different ways, because I saw a lot of people, like I think even Mythbusters had trouble recreating a lemon battery. But to increase the power of this lemon battery, since it has a typical lemon would have around 1.3 to 1.5 volts. However, our lemon batteries, they generate very little current. So with this in mind, and with an effort to increase the power of our lemon battery, we do have 6 of each kind of metal nail. So we've got 6 zinc nails, 6 copper nails, and they're all connected in series, which I'll kind of walk through a little bit more. But another option too that I saw was using multiple lemons, but for our project we're only supposed to use one lemon. But yeah, you could put like the zinc in one lemon, the copper in another, and repeat that, and again connect them all in series in a similar fashion. But again, today we're opting for our single lemon with our zinc and copper nails in this one lemon connected in series. So again, I've got 6 zinc nails that I put all in one row on one side of this lemon, and they're all about 1 or 2 centimeters apart. I tried to make sure that these nails were not touching whatsoever. And then right across from them, again in a row, I've got copper nails that are all about 1 or 2 centimeters apart, not touching. And then here I have just some wire that I cut up, and I'm connecting, starting at this first zinc nail. I hope you can see this. Starting at this first zinc nail, I connected it to the second copper nail and kind of went down that way. So when I connected to the last copper nail with the second to last zinc nail, we have one free zinc nail. And then again, we have on the opposite row, at the other end, we've got the one copper nail that is free. And these are essentially our positive and negative terminals. So I even labeled it here in Sharpie. Our zinc is actually going to be our negative terminal, and then the copper is our positive terminal. Then here I've got some rubberized wire that I cut up and removed some of the rubber on each end so that I could connect it to our terminals. So I've got it connected to this zinc and this copper nail, and then this is where we're going to try to make our fire. I'm actually going to kind of just twist these a little bit, I should have done that already. Alright, so I have a pot here just to keep everything contained, and then we're going to be trying to light this steel wool on fire. Let's see, grab some of it. All right. Oh my God, there's a lot of things out here. Okay, so got the steel wool, and then some dry tinder, which is just toilet paper. I'm just gonna rip that up. It's a little windy outside, so hopefully this doesn't fly away. Alright. Let's see if this works. I'm supposed to just touch it. Hopefully you can see this. Nope. Trying to move it around, see if anything will happen, but yeah, it's not working. Okay. So I'm just going to talk a little bit about what should be happening. So this type of battery is an electrolytic cell. Oh my God, a fly just flew into my eyeball. is an electrolytic cell, or in other words, a chemical battery. It's similar to the batteries that you would find in your everyday life and everyday items, like the batteries you would find in a TV remote or your game controller. So Volta, who made the first battery, he relied on salt water to act as the electrolyte. Obviously, we're not using any salt water with our lemon battery. In fact, our lemon, which is why it was important to have it, to roll it around and make sure there's a lot of juice that's flowing. The juice inside has citric acid, and that is going to be acting as our electrolyte. And then for our zinc and our copper nails, those are going to be essentially our electrodes that we connected in series with our wires. So these are all inserted into our lemon and interacting with the citric acid or the lemon juice. And the zinc is actually supposed to dissolve in our lemon juice, and it's supposed to produce a zinc ion with a positive 2 charge. It'll lose those 2 electrons per atom, and that will move through our wire to our copper nail. Sorry, I lost my place. So it's going to move to our copper, and then since the zinc is the one that's going to be losing our electrons, this would be our oxidation reaction. Now, the citric acid in our lemon is a weak acid, so it's going to partially dissociate and leave some positively charged hydrogen ions. These hydrogen ions will combine with the excess electrons that have traveled to the copper electrode, and it will form like a hydrogen gas in a reduction reaction. So in theory, our reduction and our oxidation reactions, which were the zinc losing the 2 electrons and then our hydrogen ions combining with the electrons to make H2, those should have generated electricity, which should have traveled through here, these wires, and created theoretically our electrochemical fire with our steel wool. Obviously it did not work. Some things that I made sure to look at or troubleshoot, I guess, was none of these wires, they're not touching, so that's good. They are connected in series from zinc to copper. The lemon is juicy. At first this wasn't really a juicy lemon, but there is definitely juices in here because as I was inserting the nails, like juice was coming out. And these are copper and zinc. It's not plated or anything, so yeah, it did not work, but that's alright. I think we understand the chemistry behind it. So yeah, that is my lemon battery. Thank you for watching.